Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have c plus 1 divided by 1 plus c is equals to 4, and we solve this problem for all the values of c. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move towards the solution of this problem from first method. Here we move the term 1 plus c to the right hand side, and we get c plus 1 is equals to 4 times of 1 plus c. And now we multiply this 4 separately on both of these two values, and we get c plus 1 equals to 4 times of 1 becomes 4, and 4 times of c becomes here 4c. And now in the next step we move the term plus 1 to the right hand side, and we get 4 plus 4c minus 1. And further we have 4 minus 1 becomes 3 plus 4c, and in the left hand side we have c only. And now for all the values of c we need to take a squaring on both of the sides, so we write it here in this form. And now we use the nice algebraic formula. You know about that. If we have x plus y whole square equals to x square plus 2 times of xy plus y square. So according to this nice algebraic formula, we expand the right hand side of the above equation as this is c square equals to, and we apply this formula here, and we get 3 square plus 2 times of 3 into 4c plus 4c and its whole square. And now in the next step we need more simplifications here, and we get 3 square becomes 9 plus 2 times 3 becomes 6, 6 times 4 becomes here 24c plus this 4 square becomes 16 times of c square. So in the left hand side we get also c square. And further in the next step we move the term c square to the right hand side, and we get 9 plus 24c plus 16c square, and this positive c square becomes negative c square, and this whole equation is equals to 0. And further we have 16c square minus c square becomes 15c square plus this is 24c plus 9 is equals to 0. So you see that this after little bit simplification we get our given equation into the quadratic form. And now here you know that there are three methods to solve the quadratic equation. The first method is factorization method, second one is completing square method, and third one is by applying the quadratic formula. So here we apply the quadratic formula to solve this quadratic equation. So here we use the factorization technique. Okay, so you can also apply the quadratic formula or any method, but here I can use the factorization technique. So now we break the middle term, and we have this is 24c, and we write it as 15c plus 9c and plus this is 9, and this whole equation is equals to 0. And now you see that both of these two terms involve 15c, so that we take common 15c from here, and we get the remaining values are from here. We get c plus from here we get 1, and here we take common 9, and we get the remaining values are c plus 1, and this whole equation is equals to 0. And now we see that both of these two terms involve c plus 1, so that we take common the factor c plus 1 from here, and we get the remaining values are 15c plus 9, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write c plus 1 is equals to 0, and the second case is we write 15c plus 9 is equals to 0. From here we move plus 1 to the right hand side, and we get the value of c is equals to minus 1. And from here we move the term plus 9 to the right hand side, and we get 15c is equals to minus 9. And now here our target is to get the values of c. So for this we divide both of the sides by 15 and we get this, and this are gone, and here we get c is equals to, this is 3 times 3 becomes 9, 3 times 5 becomes here 15. So here we easily get the value of c is equals to minus 3 over 5. And now you see that in this method we get these are the two roots of the given equation. But now in the next step we need to verify that is these roots be the solution or is these roots be the extraneous root. So for verification of this we need to copy down given question statement. Here it is c plus 1 divided by 1 plus c is equals to 4, and in this side we verify c is equals to minus 1, and in this side we verify c is equals to minus 3 over 5. So first we need to focus on c is equals to minus 1, and when you put it here we get minus 1 plus 1 over plus 1 minus 1 equals to 4, and we get 0 over 0 form equals to 4. This shows that c is equals to minus 1 is not satisfied our given question statement, so we call that c is equals to minus 1 be the extraneous root of the given equation. And now in the same pattern we verify the second value of c, and when you put it here we get minus 3 over 5 plus 1 divided by 1 plus minus 3 over 5. So this will becomes minus, okay, and this is equals to 4. And now we take the LCM of numerator and denominator terms, and we get minus 3 plus 5 divided by, again take the LCM and we get here 5 minus 3, and we check that is this equals to 4 or not. This and this are gone, and minus 3 plus 5 becomes 2 over 2 is equals to 4, and we get 1 equals to 4. These two values are not equal, so finally we conclude about that this question has no solution because both of the values does not satisfy our given question statement. So this is our final answer.